Okay, derivation of Schwarzschild spacetime in 5 minutes. So let's do it. This is the general black hole spacetime, spherically symmetric, and we have to find the Ricci tensor and put it equal to 0. So we have two Ricci tensors for the given spacetime, and they are u double dash plus 2 over r u dash equal to 0, and the second one, this is first equation. The second equation is r u dash plus u and minus 1 equal to 0. So we have these two equations. Okay, this is equal to 0. So in fact this is, so we have to satisfy these two equations. Find u that satisfy these two equations. So let u dash be v, so that u double dash is v dash. So the second equation implies then that v dash plus 2 over r v equal to 0. The integrating factor here is r square. So multiply this equation with r square, we see that r square v dash plus 2r v equal to 0, and we see this is the differential of r square and v equal to 0. So integrating, we have r square and v is equal to some constant 1. So v is equal to c1 over r square. Now v is equal to u dash, so this is u dash is equal to c1 by r square. So what is in fact u? Integrating this equation again, we have u is equal to another integration constant minus c1 over r. This is u if it satisfies equation 1. So we have to put equation, this is in equation 1, equation 2. Equation 2 implies that r into u dash. So u dash mean c square c1 by r square. It is given here, this is u dash, and then here is u, so you have to put u totally here, c2 minus c1 over r and minus 1. This should be 0. So you see this will cancel with this one, and c2 is in fact 1. So what is u now? U is 1 minus c1 over r. This is u. This is the solution of these two equations. So what will be the Schwarzschild equation look like? It will be d square is equal to 1 minus c1 over r dt square minus dr square over 1 minus c1 over r minus r square. Let me write it down. R square okay, that is the miss. So minus, I'm writing minus here, minus r, this is not r square into d theta square plus sine square theta d phi square. This is the Schwarzschild metric, but this C1 is a parameter, so usually we put C1 is to m, where m is mass, a black hole. Mass of black hole. Okay, so when I put C1 to be 2m, the metric will take this form: d square 1 minus 2m over r dt square minus dr square over 1 minus 2m over r minus r square d theta square plus sine square theta d phi square. So this is the Schwarzschild metric.